In this video, we are covering function transformations. And there's going to be a few terms and a few new notations that I'm going to have to point out to you as we go through this video. Don't panic. I'll define every new term and every new bit of notation as I go. So first, I'm going to define what a function transformation is. A function transformation, okay, that's fine. A function transformation occurs when you take a defined function and you alter it in some way in order to produce a new function. That's what a function transformation is. So I just told you, and now I'm going to write that. And what you see me writing, you should probably be writing in your notes as well. A function transformation is when you take a given defined function and you alter it, in some way to produce a new function. Okay. Now, that's what a function transformation is. Now, the given function, the original function that you started with, that you ultimately end up altering, that's known as the parent function. And I'm going to give you that definition too. The parent function is the original function that's a little sloppy. The parent function is the original function that you ultimately end up transforming. That's the parent function. And now I'm going to define the child function. The child function is the function that you get as a result of transforming the parent function. The child function is the function that you get as a result of transforming the child function. I'm sorry, the parent function. The child function is the function that you get as a result of transforming the parent function. So we got our definitions. We know what a function transformation is in plain English. We know what the parent function is. We know what a child function is. Perfect. Now let's show some examples. Let me show some examples real quick. So I'm going to start with a function, an original function. Let's call it f of x. And let's make f of x equal to, I don't know, 1. Let's make f of x equal to x squared. Okay. This is our original function. This is going to be our parent function. So this whole thing is our parent function. Whoops. Our parent function. Okay. And this right here, this side of the equation, the right side, the side with the mathematical expression, this is going to be known as the definition of our parent function. So anytime the actual equation that the function is equal to, that's known as the definition of the function. So this is the definition of the function f. Okay. And this side is known as the name of the function, the function's name. And I'm pointing this out because I'm going to use these terms. So I just want to make sure everybody understands what I mean when I say give me the definition, or we're looking for the definition of the child function. It means I'm looking for the actual equation that the child function is equal to. So yeah, the function's name. This is the function's name. Okay. So I got my parent function, f of x equals x squared. Now I'm going to show you all a transformation of the function f of x. Okay. This is a transformation. So I'm going to do f of x minus 3. Okay. This is a transformation of the function f of x. Okay. Now remember what I said. When you transform a function, the result is a new function. If it's a new function, it needs a new name. And so I'm going to give it a new name. I'm going to call this function, I'm going to call it f prime of x, right? So this is the transformation of f. This is me defining the transformation of f. This is me specifying how f is being transformed. And I'll explain how to interpret this in just a second. I haven't explained to you how to interpret how f is being transformed. I will do that in just a second. But for now, I just want to go over how just the fact that we're going to give it a new name. And the reason we're giving it a new name is because it's a new function. Now, it's a new function that is born from its parent function, f of x, but it's its own function nonetheless. So just like your parents have their own name, their own first name, and their children have their own first name, even if you're a junior. So I'm a junior, for instance. My dad's name is Jesse. My name is also Jesse, but it's Jesse Jr. It's not just Jesse. Similar concept. Parent functions have their own name. In this case, our parent function's name is f. The child function is going to have its own name. In this case, the child's function name is going to be f prime. So this is the child function's name. This is the child function's name. This is the transformation This is the transformation of the parent function. Okay. So the transformation of the parent function produces a new function. That new function gets its own name. We call it f prime of x. The new function is a child function. It's classified as a child function of the parent function. Okay, so now that some of this terminology has been used and understood, now what I'm going to show you all how to do, I'm going to show you all how to get the child function's equation. How do you actually get the equation of what the child function is equal to? We know that the child function is obtained by taking the parent function and transforming it, but how do we actually get the equation for the child function? That's what we're about to do now. Now, there's two different ways to perform a transformation of a function. You can transform the input of a parent function to get a child function, or you can transform the output of a parent function to get a child function. And I'm going to show you how to do each way. Now, this example here, this transformation, f of x minus 3, where the transformation takes place inside the parentheses, this is us transforming the input of the parent function to get this child function, f prime of x. And when you do that, when you transform the input of the parent function to get the child function, the way to get the equation for the child function is to do this. You're going to do the following. You're going to look at the equation of the parent function, and everywhere you see an x in the parent function, you're going to replace that with whatever is inside the parentheses of the transformation. So in this case, we got x minus 3 inside there. So in the parent function is defined as x squared. The equation of the parent function is x squared. Everywhere I see an x, which in this case is right here, I'm going to replace that x with what I have inside here. That's an x minus 3. So let me do that, and let me show you what I end up getting. So when I do that, the equation for f prime of x, the child function, the equation for f prime of x is going to be equal to not x squared, right? It's not going to be equal to this. What I got to do is I'm going to put x squared. I'm going to just put that as a placeholder, but it's not equal to that. Everywhere I see x, I'm going to erase it, and I'm going to substitute it. I'm going to substitute it with x minus 3. So this is what the equation of the child function is. It's not x squared, which is what the equation of the parent function is. We defined the child function as being this particular transformation of the parent function as being f of x minus 3, close parentheses. So the parent function, but instead of the typical x input, our input is x minus 3. So everywhere we saw x in the parent function, we replaced it with x minus 3. And that's how we got our new child function. That's how we got our new resulting function, our function transformation. And so in this case, that is parenthesis x minus 3, close parenthesis, squared. And this is how you would transform the input of that parent function. Let's do another example of transforming the input of the parent function. So I'm going to do another function transformation, same parent function, and I'm going to do 2x instead of just x, right? So this is a different function transformation. This is a new function transformation right here. And instead of having x as the input, I'm going to have 2x as the input. So this new function transformation, it's going to get me a new function. We'll call that function f double prime of x. It's a new child. Every child gets their own name. So this one isn't going to be called f prime of x. It's going to be called f double prime of x. And f double prime of x, again, I just transformed the input of f of x. F double prime of x is equal to f of x with the input transformed. So how I get the equation for f double prime of x, I just take the equation for f of x, which is x squared. I just take that equation, but everywhere I see x, I'm going to replace it with 2x. I'm going to replace it with what I have here, with the transformation, the input transformation. Okay. And so I would have 2x squared. F double prime of x is equal to 2x squared. Okay. Now, let's do an example where the function transformation doesn't happen on the input of f, of the parent function. Let's do an example where it happens on the output of the parent function. So let's say we got f of x plus 8, okay? And this gets us a third child function. We'll call that f triple prime of x. Now we want to get the equation for f triple prime of x. So we just transformed our parent function again. But in this case, we didn't transform the input. We're transforming the output. How do we know? Because the transformation isn't inside these parentheses. It's outside the parentheses. When it's inside the parentheses, we've just transformed the input. When it's outside the parentheses, we've transformed the output. And now I'm about to show you all how do you get the new resulting child functions equation when you transform the output of the parent function. This is how. All you gotta do is take whatever f of x is equal to, which we know what f of x is equal to. F of x is equal to x squared. So all you gotta do is take whatever f of x is equal to, substitute f of x with the equation that it's equal to, which in this case is x squared, and then add that transformation at the end, that plus 8. And now you got an equation for f triple prime of x. Let's do another example. Let's say I got the transformation f of x. Let's say I got the transformation 2 times f of x. Okay. That's going to get me another new child function. We'll call that f quadruple prime of x. Now, how am I going to get the equation for f quadruple prime of x? I'm going to do that by just looking at the transformation here. just taking a look at the transformation. Okay. And pretty much I'm just going to write it down, but I'm going to substitute f of x with the equation that is equal to. We know f of x is equal to x squared. So f quadruple prime of x is equal to 2 times x squared, which I can write as 2x squared. Okay. And this is how you transform functions. This is how you transform functions. You gotta have an original function. You start with some original function. In this case, the original function was f of x equals x squared. That original function is our parent function. And then you got to have some transformation described or defined. In this case, this is the transformation that was defined. That transformation that's defined, that transformation is either going to take place on the input of f or the output of f. If that transformation takes place on the output of f, you're going to do something. If the transformation takes place on the input of f, you're going to do something different. Now, each transformation on a parent function produces a new function. That new function is known as a child function. Each child function gets its own name. Okay? In this case, we call the child function f prime of x. In this case, we call the child function f double prime of x. In this case, we call the child function f triple prime of x. In this case, we call the child function f quadruple prime of x. That's a mouthful. Every function, every new function gets its own name. Okay? Now, if your transformation is occurring on an input, on the input of the parent function, if you're transforming the input of the parent function, which we're doing here, again, you know if you're transforming the input of a parent function by observing whether or not the transformation takes place inside the parentheses or outside the parentheses. If the transformation takes place inside the parentheses, then your transformation is being conducted on the input of the parent function. And in that case, if the transformation is being conducted on the input of the parent function, that transformation, which is producing a new child function, to get the equation of that resulting child function, all you got to do is take the equation of the parent function, the original function. So in this case, f, we take that equation. In this case, it's equal to x squared. Write it down. Okay, so to get the new resulting child functions equation, we take the original parent functions equation, which was x squared, and everywhere we see x, we're going to replace it with the input's transformation. So in this case, the input's transformation was x minus 3. So everywhere we saw x in the parent function, we replace it with x minus 3. And that got us our equation for our resulting child function. Okay? Now, if the transformation is taking place on the output of the parent function, all you got to do in order to get the resulting functions, aka the child functions equation, all you got to do is take the original parent functions equation and just copy it. Copy it right down. Copy it right on down. Write that down. And then add or perform whatever transformation is specified on the output. So in this case, it's saying add 8. So we took the original function, f of x. We took its equation, the original function, f of x. Its equation was equal to x squared. So in order to get the resulting, the child function's equation, this is the name of the child function. This is the equation of the child function. In order to get this equation, all we had to do was take f of x, the parent function. We took the parent function's equation, which was x squared, and we just added the transformation on the end of it. That's all we had to do. And that is how you perform transformations of functions. Now, these transformations are gonna they're gonna affect the graphs of the functions, okay? And now I want to show you how it affects the graphs of the functions. Maybe I'll do that in another video. I'll do that in a separate video, actually. This one is probably already long enough. I'll leave this one here. Peace.